My name, for those who don't know, is Doug Turnbull. I work as a trainer on Maven to build a work create a have a class called Cheat at Search with Agents. Really, it's about using agents and LLMs to build more relevant search. The price for this course, as people may have heard from me, is going up next year, and there's a discount code for 20% off that expires today. So if this is something that interests you, please feel free to go ahead and grab a discount and pay for it today, because otherwise it's going to be probably a lot more expensive next year. So yeah, check it out. I'm teaching all about agentic search, which I last Friday I gave a talk about. Some people may have seen that, but just all about how I think agents are going to be pretty heavily remaking the information retrieval landscape in the honestly, next 6 months, next year, and will change a lot about how we build applications. Um, Today, what I'm going to talk about SearchArray, which is a project I worked on, a side project for 2 or 3 years. It's something that I got into just out of frustration with how search engines, full text search engines tend to work. And today I'm going to complain about search engines, DSLs. I'm going to pick on Elasticsearch unfairly, in large part because I feel like Elasticsearch has kind of I don't know if set the standard, but the default assumptions that people have when working with a full text search index. And now a lot of the vector databases, as they're adding full text search, they're almost like looking at Elasticsearch as like something they're trying to help customers maybe replace or add functionality to their systems so that they can, get those customers and that kind of thing. So really, this is about maybe rethinking the problem from first principles instead of just copying what like Elasticsearch does. So I'm picking on them unfairly. So dear Elasticsearch friends, please don't take offense to anything I'm saying. So let's get started. If you're not familiar with full text search, well, the most straightforward thing to think about is we have some text. This is document ID 1. These shoes are some nice blue shoes. We won't find a better shoe. We tokenize it, and you can see we have basically a list of strings now. We've um, we've basically gone through and broken these up, and you can see we've done things like stemming. We've taken off the end of shoe. We've lowercase things. We do all kinds of things in tokenization to build the tokens that we're going to index. And we put them in our index, and this is the inverted index. Now, if someone searches for blue or shoe, we can see what documents they occur in. And that's the core thing that happens in a search engine. We do these like lookups in this dictionary, enumerate document statistics back, and compute scores. And I'm going to argue that I feel like we've made this needlessly complicated. With term stats, of course, this is on the left. What I showed before is an incomplete picture. With term stats, we have actually a lot more data here. We might have positional data about what position these things occur in. And of course, nothing here is actually logically represented as like this YAML looking thing I've put here. It's just kind of a convenient thing that I've created just for visual purposes. If you go to like Lucene, which is the library under Elasticsearch, it has been optimized to the nth degree to make this lookup of terms and enumerating the documents extremely fast. And then we compute from those statistics TF-IDF like stats. Like we know if a term occurs 3 times before, this is 3 times here because we saw it shoe 1, 2, 3. We know more term frequency means more relevance, but you probably, if you're not new to search, you know also that rare terms also are tended to be weighted highly. So rare terms mean lower document frequency. In this case, the term shoe occurs in 4 documents. Uh, so we divide our term frequency, we divide that by 4, the document frequency, and that's what we call TF-IDF. Term frequency times inverse. Inverse is just 1 over document frequency. So basically TF divided by DF. And this is the raw TF-IDF. And of course, we've optimized this to the nth degree. We have BM25 now, which is like fancy TF-IDF, and all the same stuff is in here. It's just someone has done a lot of research to see what formula tends to map most cleanly to human senses of relevance. Honestly, particularly on a lot of this stuff happened on old Trek data sets that tended to be articles of text. But BM25 continues to be a very powerful baseline used in RAG contexts, used all over the place because it's so ubiquitous, it's fast, it's relatively intuitive and straightforward keyword full text search system. And by the way, everything I'm talking about is today is entirely full text search, setting aside any vector search concerns. So now, of course, we run a query. We have a query for blue shoes. We look up in this dictionary and we pull back some term stats. So blue shoes, we tokenize blue shoes, first of all, probably the same tokenizer that happened at index time. We do this lookup. We pull back some stats, BM25 or otherwise. And maybe we combine those. Maybe we got some stats from different fields because we're searching not just the description but the name. We have to combine those somehow, those different scores, to come up with a final relevant score for our documents. So you might imagine that like you want to say, okay, I'm searching product name and description. If it occurs in product name, if the BM25 score of product name is 5 and description is 3, I'm just gonna add those. That's the sum here, and I'm gonna give a final score of 8 or something like that. And honestly, this is 90% of what a search engine does. Tokenize queries to terms, look up those terms in some dictionary, compute BM25 using the stats it found, and then do some follow-on math, what is often called the ranking function. This is like 90% of search engine functionality. And I feel if you look at this from first principles, most search engines have made this um, very complicated, unnecessarily so. Any questions so far? No? Cool. Don't hesitate to use chat. Don't hesitate to raise your hand, whatever makes most sense. Very interactive. So now I've told you that you should be able to look at this JSON on the left and tell me how this will work. You should be able to look at this and tell me how the query is tokenized, how the how the ranking function is is built. And I'm going to argue I think it's not very clear. So I'll walk through exactly how that happens because I feel like we're building DSLs that aren't necessarily intuitive to I just need to look up some terms in a dictionary, compute some stats, and use math to compute a score on a document. Well, we start with the Lego pieces. I'm going to assume basically pretty straightforward tokenization. Blue shoes, and you can see it's basically every term to every product name. Okay, we compute BM25 scores. Well, the other thing that happens is the term scores are summed in each field. So you have blue in product name, shoe in product name, blue in description, shoe in description. This is because it's a best field search. And I'm not going to necessarily tell you in this talk what is a good way to do this. I'm just trying to help build a better way of reasoning about how search engines work. Well, we're boosting product name by 10, so we multiply that by 10. And it turns out best field actually just means take the max field, the field with the highest score. And so we end up with 150. And it's not that crazy when you internalize this. And if you've done Elasticsearch for a long time, this is probably second nature to you. You know these query patterns and you know kind of how they work, and you probably have a sense for how to apply different parts of the query DSL to different problems. But what happens when one field is one? field is tokenized differently. So tokenization can mean lots of different things. It can mean compounding, decompounding. It could mean synonym expansion. It could mean turning things into what are called shingles or word engrams. It could mean like building character engrams from the front of a field. And this is where things get really confusing. And where honestly, I'm tired of spending all my consulting time because I feel like they're not the fun problems, but they're problems that come up all the time that screw up people's search. So here, what do we do in this case? Well, how does this supposed to work? Blue shoes, and then we have blue underscore shoes. Okay, you have to know that that's going to happen. Okay, maybe that's relatively straightforward, but what do you do if you have a synonym like shoe and footwear? Do you take the max of the synonym? Do you take the sum? These two are kind of overlapping as the same unit. Uh, it might be weird to take the sum, but then again, it kind of makes sense. How exactly do you do that? And it turns out that there are ways it's a really deep kind of trivia of a Lucene search engine, how this works. And it works differently depending on if you're using a phrase or a term. And then what do you do if like blue shoes all this is collapsed together? Blue shoes is concatenated, but you also have all of these things. So you get really confusing scenarios in the Elasticsearch and generally in these Lucene search engines where a lot of hidden state about how these fields are tokenized can really dictate and confuse how the final relevant score is computed. And it changes. So if we change to most fields, well, if you know Elasticsearch, we would say, well, we take a sum. And then if you do this on the left, if you know Elasticsearch, you know this adds the score of the footwear searched of product category should somehow equates to adding. So that's going to be additive to the final relevant score. Yeah, it's added. Uh, so I think we have kind of been the frog in boiling water, and we've been a bit if you're in the community, you just take this for granted as some expertise that you need to have that you've had for years. But I think this is a bad system. I think this is not a good way of expressing math. In fact, we have ways of expressing math, and it's called math. We could just look up some terms in a dictionary, get some stats, and compute some scores, and then literally add them if we wanted to. Um, but it doesn't stop there. You have to know it's not just these like things I've told you so far. The math that is available to you is constrained. So you might know if you've used Elasticsearch or things called a function score query, which is like a kind of Gaussian decay. There are things like combined fields, which actually do blend document frequency across fields so that like fields are if something is rare in one field and common in the other field, it behaves a certain way. There are filters that act as like if statements. You have to know that must is a mandatory clause, but it also participates in scoring by adding to the overall Boolean thing. You have fuzzy prefix queries, etc., that look parse of terms. You have scripting, which is open-ended, but also feels kind of icky because you're asking like Elasticsearch to compile arbitrary JVM code. So there's just a lot here that is you have to keep in mind. And then when you pile on that, all of the ways that things can be tokenized, it gets even more confusing. So I've already walked through that quite a bit, but yeah, I've basically said this. And this is for the longest time, I feel like the complexity and the wrong-headedness about how this has been designed, if we were actually to think about this from first principles, is creating tremendous consulting opportunity as like a side effect. And you can see me on the right. And it kind of prevents us from getting to the meaty and interesting problems that might be in full text search. So yeah, it's very confusing to a newcomer, especially if you have a background in a lot of newcomers in full text search are coming from a background of maybe data science or machine learning engineering. They're looking at the system and sort of have a mental model of how a database works. It's rather confusing. And yeah, but search engines are like this is Sparta. But it's also really crappy for people like me who've done this too long, the professors of the world that sort of see this as like a crutch. It limits the amount of ranking math that they can use. And this is actually really important because we're at a point where in the in not just full text search, but information retrieval of tremendous innovation with RAG and agentic search and other just vector search and everything. It's like we we don't want to if we are in a place of extreme innovation and hamstringing people to like a couple of mathematical forms that for some reason we've considered valid and not letting them experiment beyond that is really limiting. Yeah, and same, what also happens is you have a limited set of tokenization options just based on whatever's in Elasticsearch or Lucene. So you have analyzers and you have other things. But quite often you want to interact with some external synonyms database instead of putting synonyms in Elasticsearch or something. And so you kind of break your tokenization. So some of it's done in your query API and some of it's done in the search engine. And that gets kind of crappy. Uh, whereas then you also have way more. If you were to look at Python, Python will have always have more tokenization options just by being able to do string.split and then massage the resulting things that come out of that in many different ways. If someone is going to write a lemmatization library these days, it's first going to be done in Python. It's not going to be done in an Elasticsearch tokenizer analyzer thing. So I literally think we should just be able to write this code. Tokenize query to terms like in our API. I think I'll talk about this, but I don't think tokenization should be the job of full text search engines. Look up term stats in a Python dictionary. Compute BM25, and then do some more math. Like we have the technology to do this. I'll stop. Any questions so far? I'm gonna assume that I'm brilliant and you all love everything I'm saying. Okay. All right. Or statements or debates. I'm also happy to be questioned because I'm coming very hot into this talk with strong opinions weakly held. So I've internalized that lesson that I was beaten into me as a staff and principal engineer that I need to have strong opinions weakly held. So feel free to question them. But tokenization, so yeah, tokenization can happen outside the search engine. I can recreate a stemmer, a traditional snowball stemmer that you would have in Elasticsearch. I can do things like ASCII folding. I can do everything I can do in Elasticsearch and more in a very basic Python function that takes text and returns a list of the tokens. So here is a list of stemmed Mary had a little lamb. Um, it's not that hard. It's actually in some ways easier and more flexible for me to do this. If I had some kind of synonym database lookup, I could then go and grab those from my database and inject them into here and do all kinds of crazy things. So I can do this. I think we should be doing this at index time and query time. We shouldn't be piling this stuff into the search engine. In part because the other thing is if you're using some random vector database, Elasticsearch has actually developed a tremendous library of tokenization options. If you're like grabbing Weaviate or something or some random vector database, it's probably the case that their options are more limited. Um, and you'll probably be thinking, can I do this outside the search engine anyway? And in fact, TurboPuffer gives that as an explicit option, just tokenization outside the search engine. I think we should just let the ranking math be math. So, oh, Nadia asked a good question. Tokenization frequencies from a Python library, are the frequencies taken for specific context, your specific marketplace? Do you mean like the term frequencies? The term frequencies are like the count, just how many times. Like I think earlier I had shoe was just in a paragraph and it would be like mentioned 3 times. So that frequency is just a word count of like if you see a list of tokens, shoe is like the occurs 3 times or something like that. So if we pass that token stream up to some search engine, the theoretical search engine I'm talking about, it should be able to do that count for us. Although it's interestingly, uh, well, we need to apply the function in Python and then apply the terms in ES. Nicholas is questioning if it will make debugging more complex. Um, it definitely could if you would definitely need to do that. You would definitely need to do tokenization outside the search engine before going to the search engine. So that's a good point. So, yeah, I think we should just be able to do math. I should just be able to take scores equals title score of this term plus description score of this term plus the max of these two for some reason. Um, I don't know why we're expressing math in a DSL that was written to basically replicate a query, like a fielded query syntax from the late 90s. We are in a much more advanced phase in information retrieval, and it feels like we need to be updating the ways that we think about this. Vespa actually has in its ranking profiles, I really like that they just express math, that that's what they do. And I think that's one reason Vespa is becoming more popular. And we have data frames and we have array-based programming that let us think in terms of this. So many people have probably used Spark. There's polars, which lets things be sort of lazily evaluated. There's pandas. I don't know why we couldn't have a system that thinks in terms of a DAG of these operations. Like, even though I've laid this all out, the whole thing could just be a DAG that gets kind of built and then executed on the server. But of course, there's also just pandas, which is just what I'm actually going to talk about, which is in memory, an in-memory process that's eager, that's always executed right on time when you ask it to. Yeah, that's exactly what I said. This is really my dream is I want to be able to express arbitrary math and then have a DAG that some backend system executes at query time that's fast enough to get like some top end results at query time. Let's see. Roshan asks, is there a decision matrix guideline mental model you have when you say yes, do tokenization outside the search engine or don't do tokenization outside? The main thing, I think, if your tokenization is getting more complex than maybe basic, which it can very quickly become. If it's getting more complex than your basic language specific stemming, I think it's probably better to do it outside the search engine. So if it's anything other than like break into what I don't think search if a search engine supports tokenization, in my opinion, it should support relatively straightforward things like break apart tokenization, do lowercase, of course, stemming, remove punctuation, like those kinds of things. I think when people start getting really fancy with analyzers and synonyms in the search engine, they're asking themselves for trouble. Any other questions so far? I know I've been opinionated. Meant to be an opinionated talk. Okay. The other thing that happens with tokenization is it can be a performance problem. So you could imagine you have a search engine that is serving queries and periodically it's indexing documents. Sometimes when you're indexing documents, like tokenizing queries is not a big deal for the most part. But when you're indexing documents and all of a sudden you're tokenizing thousands of Word documents while you're trying to serve queries, that tokenization, especially if it gets complicated, but not even if it's simple, can be a performance, can just eat up the CPU of that search engine. So what have I built? So one thing I've built as a different way of thinking about the problem, I built this thing called SearchArray, um, which people have probably heard me talk about. It's the primary tool I use when I give training because it's entirely in memory. It's based in Pandas. It's a Pandas extension array, if you know what that is. But it basically acts like a NumPy array. You just create your own Python tokenizer function like the one I showed before. It just has basically one method. You can index documents, but after that, there is basically one method to score to get an array of scores. So we return BM25 scores for the term or phrase you pass in. And by the term is tokenized outside. So you are tokenizing and then just calling score on whatever you just tokenized. And then once you have an array of like BM25 scores for this token in this field or this phrase in this other field, then it's just like NumPy math. You can do all kinds of stuff, and I'll show what that looks like. And you can pass the other thing, you can pass an arbitrary similarity to score to change out how stats are computed at query time. So default is BM25, but if you wanted to do something else, and I'll show that in a second, you can totally do that. So let's jump to a Colab notebook because this is more fun in Colab. But before I do that, any questions so far? Cool. Thanks so much for the chat questions. Mm. So, yep, good call. I will put it out there. If you go, so let me put links in the chat right now. There's, whoops, I just shared the slides, but I meant to share which I will make public right now because I just shared them. And I will also share the collab notebook that I'm about to look at. And I will also put in the link for SearchArray itself. Cool. And there are notebooks from SearchArray. So let's look here. You could ignore this, just installing the dependencies. This is the tokenizer code that we saw before. Let's see if it's from, okay, good. I'm going to load a corpus that is people have heard me use a million times because it's convenient, which is the Wayfair furniture dataset, which is about 50,000 documents. So pretty convenient for dorking around with ideas in a Colab notebook. Search array is probably it's not this magical DAG thing that I would like to exist. It's more of a conversation starter because it's more focused on in memory. It works well for up to like a million or so documents that tend to fit well in memory. It doesn't, it's purely something that you might work in a Colab notebook, or some people use it in uh, for smaller jobs or building smaller indices to play around or have some flexibility. So indexing here is just how you index with search array. Search array, so we have this corpus that's just a pandas data frame. You can see what it is. And I'm going to add two columns. One is title and one is description. So all I'm doing is search array.index. This is making the magical actual search array. Uh, it's going to use this tokenizer when I index it. So it creates a list of tokens and puts them and indexes them. Um, we can see what the tokenizer does, which I already showed before. And we're going to have this query blue couches. So before we had this best field search, which I complained was confusing. Uh, I find this is basically the same thing implemented in what SearchArray would do. So I have my overall scores. I'm going to loop for each field. I'm going to get, like that. I don't like the plural in the name. I'm going to get for each token, I'm going to get a BM25 score in this field. So first title snowball, blue, title snowball overview. And if you remember from before, best fields takes the maximum of the two field scores. So uh, score starts at zero. So the first field score will just be the title snowball, and then the next one will be whatever's higher for that document title or description. And scores here is just literally an array, a NumPy array of whatever the length of the corpus is. And anytime I call score, that's what I'm getting back. So if I come up here, let's see, this is computing BM25. So let's see, blue. Let's see, and let's make sure that I'm actually doing a valid token. So notice I'm tokenizing and then passing that to score. And it's probably just, yeah. So we got some things that are actually matches here. So all that's doing is computing BM25, and all I'm doing is accumulating that into the final scores and then getting a maximum. Um, so there's no confusion about like you can explicitly see how the query is tokenized and you can explicitly walk through how this code works. Am I suggesting using SearchArray for the dev work on the search engine and then perhaps translate it to Elasticsearch DSL? There's a couple things I'm suggesting. I'm suggesting one that I wish production search engines operated this way. So that's one thing because I feel like it's confusing how they currently operate. But the other thing I'm suggesting is yes, this is a great way to experiment with ideas and then translate if you can. Um, but that, depending on the flexibility of the query DSL, that may or may not be important. I do think this is a better environment for experimenting with completely innovative and different ideas because it's less rigid than the Elasticsearch or whatever query system you're using. And I think people could just use this for smaller search problems too. And then you can see here I compute scores and I get the top results just by sorting, getting the top 10. The other thing that's not happening that a regular search engine would do that I'm not doing, a regular search engine would be building a heap of the top results as it's going through this. But I'm literally just getting a array value for every document in the corpus. So so far so good. I might want to boost on a phrase. And here I've got a query Bowie coffee table. When I just do this search by itself, this is going to just does a phrase search. So what I'm really trying to do is push things closer to the primitives that actually matter. Like before I said, I just want to look up the scores or look up direct statistics when I can. Um, and that's what this is doing. You can either search for a single token or search for a longer phrase. In this case, this will, of course, be give me this list. And when I pass a list to score, it gives me uh, it gives me score for this phrase, this term occurring before this term, occurring before this term. So very common in search. It's not just about individual terms, it's about the position aware phrase search. So we should be able to see some that actually, yeah, you can see like there's like a document that actually has that as a phrase. So we have our search for that's the best field, and this would have been like some kind of should clause with a match phrase above it. And now I'm just adding a phrase match, and you can see somehow this one that actually has the phrase got boosted like by 10. But maybe I don't want BM25 at all. Maybe I BM25 is a big complicated formula. I could also just go back to TF-IDF, which is what this is. So this is the signature for similarity in search array. Search array has the notion of a similarity that's just math on the NumPy arrays. Uh, you can see all the things that you get, and you can literally just do term frequency times doc or TF times IDF. And now I just pass similarity here, and I get top 10 with a different, notice the scores look different. It's interesting the phrase did not completely like move this up as high. These are all pretty close to each other. Maybe there's something with the TF-IDF score, the raw TF-IDF score, this Bowie term compared to BM25. But what I get really excited about more as an advanced person is you can just go nuts with whatever math you want because this is just NumPy. And for example, what if I wanted to multiply the field scores together? I can do that here. Or what if I want to take the scores and raise it to the power of the phrase match or something crazy? Or what if I only want for scores greater than some threshold to like multiply the score by the 2 to the power the of the rating of this product. You can do all of these things, and if you understand sort of NumPy and Pandas, you basically have the full range of mathematical operators in Python available to you. So you can see you get some interesting weird scores here. One to the something one to the power 10 to the power of 12th, and then much tinier scores. So yeah, that's search array. I feel like it's a more direct access to the underlying parts of the search engine are that are actually driving relevance based in a notion of being more data frame and array based programming that I feel like makes a lot more sense to me. Um, may not make sense to everybody, but it makes a lot more sense to me as a more direct, straightforward way of thinking about search without a lot of the fluff in between. Yeah, I went through all of this stuff. So you guys breeze through this pretty quickly. Um, some conclusions. I don't feel like it's good to try to recreate Elasticsearch in every new search engine we're building or vector database. We can do something radically different. We can tokenize outside search, for example. We can think in terms of the direct scores that we're getting back in terms of data frames, and we can and more of an array-based programming mindset, even if it's executed here, I'm executing it eagerly, as in right away. We can also, it's something you can schedule to happen in a more classic execution engine on in a search engine. And that's honestly nobody here unless you actually work for a vector database company. It's not something we have control over, but I do think it's an important thing that the industry needs to rethink in terms of full text search. And I do think it's important that these engines stop being as opinionated about their math and let us support more arbitrary math when we're working with this stuff. And I think a lot of search engines that have been successful, like Vespa, um, are because of the sort of like open-ended nature of math that is supported. Uh, I don't know much about Redis search. I'd be curious to learn more. I don't know if you have experience. Someone was asking how SearchArray compares to Redis search. Well, Redis search is like going to be a in Redis, so I don't quite know much about how Redis search works. If that's as follows the same philosophy, it'd be really cool if it did. Yeah, we can turn this search array is like a limited in memory, nice to use in a Colab notebook or for small problems. Um, but I hope someone turns this into a DAG-based query execution engine uh, and turn all this math into an execution um, plan. Mary's asked, saying she provides feedback. Sometimes these companies am I saying a better open math would provide creativity and solutions? I'm saying two things. They need to be open to, they should encourage tokenization outside their search engine and not necessarily try to recreate every language's challenges. And I do think that open-ended mathematical would like expressiveness would be extremely valuable. I actually really like, it's not even that, it's like you can have a query DSL that's open-ended math, but there's also the open-ended math, but also what I really like here is that I'm just working with like in Python. I'm not actually working with a query DSL. There is no query DSL for search array. It is just math. And to the extent that we can do that as well is an even bigger win. See, Eric says, how about Pylocene? I honestly haven't messed too much with Pylocene, largely because I get a sense of a Java dependency that might be there. It could do something similar, um, but yeah, I don't have a good answer to that. Maybe. And if Pylocene did something like this, that would be amazing if it enabled this kind of thing. I suspect there are like, I know there's other full text searchy things you can install in Python that um, I don't know if it would behave in the same way that I like that search array behaves, but I think might be able to get you a similar kind of approach. Any other questions? I know I've been spicy, combative, hopefully in a good way. Uh, Nadia wants to know introduction to search. Well, that is actually a good. I have a free course that you can take, except that link doesn't work because I moved it. So if you're interested, if you do want a complete introduction just to search Nadia, uh, please come over here. You can click on any of these. I'm doing this before. This is also a great way to prep if anyone's taking Cheat at Search with Agents and you want some background knowledge. I always try to do this free course before I do that course. So there's going to be a class on lexical search in PM25, another one on vector search, and another one on evaluation. And really, my goal with this, it's very explain like I'm five as much as possible. Uh, and um, and yeah, feel free to come and hang out. It should be fun. I'll put a link into here. Any other questions? Great. Oh, interesting. So someone points out Dask. I think I've heard of Dask. Yeah, Dask is a DAG execution engine written in Python and integrates seamlessly with NumPy and Pandas. I imagine an integration with SearchArray and Dask would be nice to have. 100%. In fact, a some kind of there something like this, I think, is probably what I would be most excited about. Whether it's Dask, I know there's the various embedded databases too, like DuckDB and stuff like this, but something that's much more DAG oriented that is sort of like lazily executed and potentially a distributed system gets me excited about. But I'll have to check that out. Cool. And any other questions before we sign off? Mary? Yeah, go ahead.
Yeah, so do you see that these AI search engines are kind of coming over to the way that you're thinking and how they're kind of building out the new search? Or are you kind of on a limb about these
I
types
think
of
I'm on a
things?
limb a little bit.
Okay.
But I did this talk also, but I also did this talk because it seemed like there was some traction for SearchArray in the last week or two. So it seemed like people were excited. I had kind of put it off to the side as a side project for a year ago. Um, but I still use it like for training and stuff. And so I've been a little bit off on a limb. And part of that is just because a lot of these sort of AI search engines come out of sort of they got excited about vector databases, and it feels like sometimes full text search is like the thing they're tacking on. It's not necessarily thought of in terms of uh, first principles as like how should it work. So I think that's a challenge that they face is like um, and on the legacy search engines, you know, like Elasticsearch, Solr, OpenSearch, they're kind of like they just have like decades of inertia that they have, and I still use them happily. I kind of like try not to over configure them, and I might do more work in search APIs these days as opposed to like pushing lots of work into Elasticsearch in part because of a lot of the things I've talked about, how complex it can get with if you have a big complicated query. But I think for them, it's a different kind of challenge. They just have, we've done things this way for so long kind of perspective. Any other questions? Let's see. Yeah, same view. Legacy search, VS, and RAG do agentic search to leverage BM25. Agentic search is, say today, agentic search is interesting because I feel like so I went through this. I wrote a blog post last week that was about how we kind of went through this historical accident of thinking that RAG was a vector database problem. If you think about how RAG works, especially agentic agents work, agents and RAG work with they can understand structured tools. So they can understand like, oh, I'm supposed to think of this query as a BM25 query. I'm supposed to put a category here of this list. I'm supposed to do these things. And LLMs can be tremendous translators between what a user just wrote paragraphs of to using these tools to do different functionality and then reason about what it got back and then refine itself. And sometimes it's actually, you might say it's like more, it's clearer to the search engine when it puts in a keyword and it gets that keyword back. So you might argue that the semantic layer isn't in a RAG or agentic search system isn't the vector search engine. It's actually the LLM in itself that can do this translation between the query the user wants and how it's supposed to work with the tool. Um, and that's kind of what I argue is like we look at these things from a bit of the wrong perspective. We sort of need to describe tools that are good at finding the things in our problem, like finding, I don't know, furniture products or something based on the criteria most users care about. Well, we need to solve the search problems of each of those. You might have like a category search, you might have a color search, you might have like all different parts of a single. search tool. And many of those things might be lexical, many of them may be vector search backed, who knows? But a lot of that, a lot of the perspective we ought to think is like, how do we build good tools? Because LLMs are amazing semantic translators between what users care about to tool use. And I feel like we got like very over-indexed on vector search as like the solution, when really it's this understanding how to build good tools with lots of different technologies and do good query understanding around that that is actually the right way to think about these problems. So that's my little rant. I have a lot of rants, but that's my rant about that. Any other questions? Great. Well, thank you for those of you who are new to search and you put up with this probably more advanced talk. And those of you who are, uh, you know, could just are not new to searching, could just listen to me complain for quite a while. So I hope everyone has a great holiday if you're taking off next week. And yeah, have a good weekend as well. Take care.